This is the common strategy I see people use when multiplying numbers in their head. They'll take one number and keep it the same, and then they'll split the other number into two numbers that are easy to multiply. 3 times 4 is 12, but then we need to add two zeros. 3 times 5 is 15, and then you add a zero to that. Now to add 1200 and 150, well, we can actually split this into two more numbers. This can be 100 plus 50, so we have 1200 plus 100 plus 50, which is really simple to do in our heads. That's just going to be 1350. This is actually one of the most common strategies that I see. But that being said, using whatever strategy you would like to, I want you to try multiplying the two numbers you see on the screen. So pause this video and try solving this problem in your head. Okay, so I'm going to do this without writing anything on the screen. So I see 20 times 86, so I'm going to split that into 20 times 80 plus 6. 2 times 8 is 16, and then I add the two zeros, that's 1600. 2 times 6 is 12, and I add a zero, that's 120. So I have 1600 and 120. I get 1720. So option D is the correct answer. How fast can you solve this problem? So here we have a line, and I've given you 2 points on the line. I've given you the origin point, which is 0, 0, and the final point, which is 3, 9. Calculate the slope of this line. So to calculate the slope, which is typically represented by the letter m, it's going to be the change in y divided by the change in x, basically rise over run. So to solve this, what I'm going to do is recognize that we finish at a y position of 9, and we start at a y position of 0. So the change in y is going to be 9 minus 0. Now what I'm going to do is divide this by the change in x. We finish at a position of x equals 3, and we start at a position of x equals 0. So the change is going to be 3 minus 0. 9 minus 0 divided by 3 minus 0 is the same thing as just 3. So 3 is the slope of the line and the answer to the problem. What you see on the screen is an equation for some line. Find the slope and the y-intercept of the line. Now, to solve this problem, what I'm first going to do is take this 2 and distribute it into the parentheses. So we'll have 2 times 3x, which is 6x, and then we'll have 2 times negative 2, which is negative 4, and then of course we'll add on the plus 12 at the end. Now from here, I can combine the negative 4 and the positive 12, which will give me positive 8. So we'll have that y is equal to 6x plus 8. Now the reason I did all of this is notice that our equation is now in the form y equals mx plus b. This is the slope-intercept form, where m is the slope of the line and b is the y-intercept. Notice how the slope of our line is 6 and the y-intercept is 8. So to answer this problem, the slope is equal to 6 and the y-intercept is 8. In less than 60 seconds, I'm going to explain how to graph math functions. Imagine you are given a function like this. What I'm going to do is use the input-output strategy, where the horizontal axis refers to the inputs and the vertical axis refers to the outputs. So let's say I start with an input of 2. That's going to be our x. So what I'm going to do is plug in 2 for x. So x minus 2 squared will become 2 minus 2 squared plus 1. Well, 2 minus 2 squared is just 0, so we have 0 plus 1, which is equal to 1. What that means is if we input 2 into the function, we get an output of 1. This intersection is where the first point is going to be. Now let's try a different input. Let's say that we go with 1 this time. That'll give me 1 minus 2 squared plus 1. 1 minus 2 squared is positive 1, and 1 plus 1 is 2. So that means at an input of 1, we get an output of positive 2. This can be where we plot another point. You can plot as many points as you want to, but eventually the shape of this curve becomes very obvious. So using this method, you can graph any two-dimensional function without memorization. We have 2 to the power of x plus 4 is equal to 4 to the power of 2x minus 1. Solve for x. So what I'm first going to do is try to get the two bases to be the same. Now I recognize that 4 is the same thing as 2 squared, because 2 squared is 2 times 2, which is 4. Now by the laws of exponents, I can take this number right here and distribute it into the 2x minus 1. So I'll have 2 times 2x, which is 4x, and then I'll have 2 times negative 1, which is negative 2. Now notice after completing this step, the two bases are the same, which means I can set the exponents equal to each other. So we'll have that x plus 4 is equal to 4x minus 2, and now we just need to solve for x. So I'll subtract x on both sides, and 4x minus x is the same thing as 3x. I'll add a positive 2 on both sides to cancel the negative 2, and 4 plus 2 is the same thing as 6. Now finally, I'll divide 3 on both sides of the equation, giving me that x is equal to 6 divided by 3, which is 2. So the solution is x equals 2. Now in this problem, you can solve this problem. We have a function in the form a times b to the x power. We are given a graph of this function and 2 points on the graph. We need to calculate the values for a and for b. So the function is in this form. And the value for a is going to be equal to the vertical intercept, which is 30. The reason for this is because if you take 0 and plug it in for x, this entire term will go to 1, meaning that you'll have a is equal to the y-intercept, which is 30. So all we need to do from here is calculate b, and we can do this by using the second point that we have. So I'll take the x-coordinate, which is 4, and plug it in for x, and then I'll take the y-coordinate, which is 480, and plug it in for f of x. I can divide 30 on both sides to get b to the 4th by itself, and 480 divided by 30 is 16. I can take both sides of the equation and raise it to the 1/4 power, and 16 to the 1/4 power is 2. So solving for a and b, we figured out that a is equal to 30 and b is equal to 2, meaning the function looks like this. Now I trust that in this math problem we have a system of two equations, and we're looking to solve for y. How can I go about doing this? Well, the way I'm going to solve this problem is by using the elimination method. So I'm going to take this entire bottom equation that I see here, and I'm going to multiply everything by 4. So we'll have 4 times x plus 4 times y equals 4 times 10, which is 40. So the equation will look like this once I've scaled everything, and notice if I go ahead and subtract these two equations, I can eliminate the 4 x's. That's why I scaled this entire bottom equation by 4. I'll take negative 5y and subtract off 4y, and that will give me negative 9y. And then this whole thing is going to equal 22 minus 40, which is simply negative 18. So to solve for y, I just need to divide negative 9 on both sides of this equation. The negative 9's will cancel, and then I'll get negative 18 divided by negative 9, which is positive 2. So positive 2 is the solution to this problem, and this matches with option A. So let's talk about evaluating logarithms. So let's say that you see a logarithm like this, where you have your base as 5 and then you have the logarithm of 125. I'm going to explain how these work. So all this is saying is what exponent to your base of 5 here will give you 125. So another way you could write this is like this. So we're trying to figure out what x is here. 5 to what power gives us 125? In this case, it's going to be 3. 5 cubed will give you 125, because 5 times 5 times 5 is 125. Since this is a correct statement, our exponent is 3, which means that this logarithmic function up here is equal to 3. Now let's try a situation like this, where we have the logarithm of 1,000. Now notice that there's not a written base on this logarithm. And whenever there's no base written on this logarithm, there's going to be an implicit 10 there. So logarithms have an implicit 10 as their base unless there's specifically a number listed down here. But if there's not a number there, then it's going to be 10. So in this case, we're trying to figure out 10 to what power is going to give you 1,000. And ironically, this is also going to be 3, because 10 cubed is 1,000, so that means this is a correct statement, meaning evaluating this logarithm should give us 3. If you have a minute, I want you to try solving this function. We have that f of x equals the log base x of 16, and we're trying to evaluate f of 4. Now, if you're trying to find f of 4, what you basically need to do is take every place that you see x and replace it with a 4. So to solve this, all we need to do is figure out what log base 4 of 16 is. Well, 4 is the base that we're dealing with, and this base is raised to some exponent. That's what the logarithm calculates. And whatever that exponent is, has to get this side of the equation to equal 16. If you take 4 and raise it to the second power, you're going to get 16, because 4 squared is 4 times 4, which is 16. So the answer for f of 4 is 2. Let's simplify this natural log. Now there's a rule, whenever you're taking the natural log of something raised to an exponent, you can take that exponent and bring it to the outside of the natural log. So we can rewrite this as 5 times the natural log of e. Just like common logarithms have an implicit base of 10, natural logarithms have an implicit base of e. So basically what this whole expression is asking is e raised to what power is going to give you e. That's just going to be 1. Because e raised to the 1 power is going to give you e. And the natural log of e, whenever you see this, this entire thing is just going to become 1. So we're going to end up with 5 times 1, which is just 5. So simplifying this expression, we end up with 5. Imagine that you just took a math test and you figured out that you got an 85% on the test. You got 27 of the problems correct. How many questions did you get incorrect? Whenever you're trying to calculate the percentage of problems you got correct, what you want to do is take the total number of problems that you got correct and divide it by the total number of problems that there are. This will calculate your percentage as a decimal, and 85% as a decimal is the same thing as 0.85. Here I just need to solve for x. What I can do is take this 27 plus x and this 0.85, and I can switch them using the rules of multiplication and algebra. From here, I'm going to take 27 and divide it by 0.85. If you do this on a calculator, this evaluates to around 31.7647, which I'm going to go ahead and round this to 32. And subtract 27 on both sides to cancel the 27s on the right, and 32 minus 27 is the same thing as 5. So in this hypothetical situation, you got about 5 problems wrong on the test. This math problem is ridiculous. We have our friend Kirby, who accidentally ate a mystery box, and well, now he's a square. Kirby then eats a gigantic basketball to try and regain his original shape. If we have Kirby's volume, what is the basketball's volume? So to solve this problem, I first need to find Kirby's height. I can assume Kirby is a perfect cube, and I can set x cubed equal to Kirby's volume. I can take the cube root to find Kirby's height, and notice how this would match with the diameter of the ball. We know the diameter is twice the radius, and I can use some algebra to find r. Now at this point I can use the volume of a sphere and plug my radius in right here. Multiplying these numbers gives me the basketball's volume, which is also the new volume of Kirby. Man, this was a lot of work just to make him happy.